The topic for today is what is research? Research is defined as formal, systematic application of the scientific method to the study of a problem or problems. The goal of research is to describe, explain, predict, and control situations involving human beings. So let's think. There are 5 different ways of knowing something: sensory system, agreement with others, consulting an expert, logic, and scientific method. And you notice that scientific method is in caps, and that's where we want to spend most time talking about, leading into why we want to look at data and talk about data analysis. So sensory system is, of course, the very basic way of coming to know something. The basic 5 senses are hear, see, taste, smell, and touch. And we see babies coming to know and experience the world through these 5 senses. But we know that these 5 senses can be very misleading. What feels cold may actually be hot. And to think that we use the sensory system to make decisions that involve people is not a very strong way of making a decision. So while the sensory system is the very basic way of knowing something, how about if we come to an agreement with others and make decisions that way? We come to know something just based on what we agree upon. But we often experience things like this. Why is it so hard for people to agree, right? It's hard to agree, first of all. And if, for an instant, if there's one side of the story, there's the other side of the story, and perhaps what actually happened, what is actually factual, right? How about if we say, well, if the agreement is reached by the majority of the people, then does the majority speak the truth? While we make decisions this way, we also know that the majority oftentimes does not speak the truth. It's oftentimes the minority. How about if we just bring in somebody, consult an expert, have somebody in authority tell us, a trusted source to tell us what to do? For example, a parent, teacher, newspaper, or other source of informants to tell us what decision we need to make. Or an experienced cab driver to tell us the quickest route through a city. We can consult an expert, but sometimes that expert is also personally biased, and it is one person's opinion. So how about logic? Logic looks something like this. If A equals B and B equals C, then A must equal C. Right? The limitation with this logic is that unless the premises, the first 2 premises in this case, are correct, the conclusion is incorrect or is misleading. So there's very little room for any error in logic. So now scientific method is what we want to expand on, and that's really within the context where we talk about data and data analysis and where this course actually fits into. Experience, agreement, authority, logic are all limited and subject to error. And so when we look at scientific method of research, we'll see that this way of coming to know something is the most reliable. So scientific method of research, the goal, again, as iterated earlier, is to describe, explain, predict, and control situations involving human beings, but using the following 5 steps of scientific method of knowing. So scientific method involves these 5 steps. 1, recognize and identify a problem. Then formulating the hypothesis, which involves clarifying a problem and operationally defining key terms. And 3, determine the information needed and how to obtain it. That would be data collection. And 4, organize the information obtained. That's data analysis. And then finally, the last step is to interpret the results and draw conclusions and implications. So first, recognize and identify a problem or a question. A problem or question of interest has to be a practical one. A practical problem can be tested or the question answered through a collection of data and data analysis. So what's a practical question? So how do we differentiate that from theoretical questions? So first, let's look at some examples of theoretical questions. What is intelligence or creativity? Or how does a child learn? How does personality develop? What motivates students to learn? What environmental factors are related to student achievement? These are very good questions, but these are questions that do not lend themselves to collecting data that can directly answer these questions. Right? So these are more theoretical questions that will lead to perhaps some practical questions. So practical questions that we can ask as educators perhaps is something like this. How effective is an intervention program in an elementary school classroom? So different from theoretical is that this is asking a very specific question about the effectiveness of a certain program. So you can kind of see that this is requesting for some specific kinds of data that can then answer this question. That makes this kind of question practical or empirical. Here's a couple of additional examples. How does teaching children cognitive strategies affect their reading comprehension? Or what are the benefits of collaborative small group work in a company? All great practical questions. And then once you ask the practical question, you want to learn all there is to know about it. We want to become knowledgeable about the topic in order to know what would make an important contribution to the field. We want to know what we already know. So we want to go to the literature on the topic to understand the theoretical basis of it and to build a rationale for why your study is an important one and your research question to advance the knowledge, existing knowledge. So this requires completing all of the necessary background work, digging through the literature. And while doing that, you want to be able to see the problem from all sides, especially if there's a controversy or contradictory findings. Think through the feasibility of the project. You want to make sure that while the question is practical, it is feasible to collect data. For example, it's practically impossible to study the entire student population of Los Angeles Unified School District. So you want to look for something that's much more feasible, doable. And you want to entertain different suggestions offered by other research or researchers. In some cases, you may provide a rationale for replicating a research project to kind of repeat the same study, but in a different setting or with a different population. And apply existing perspectives or explanations to the new situation. Explore unexpected or contradictory findings in previous studies. This actually creates your study much more interesting because of the existing contradicting findings. Challenge research findings that fly into the face of what you know or believe to be true. The second step is to clarify a problem. You want to define the specific variables in ways that you will collect them. And then in step 3 is to understand what are the data that we need to collect to be able to answer your practical question. It also entails here describing the population, defining variables of the study, develop research questions, and any interventions or innovations that you are going to employ in the study. And you want to develop a statement of purpose, timeline, and data collection ideas. And then in step 4 is to then try to make sense of the data that you have collected. And this is where our course material that we will talk about for the remainder of the semester will fall into. data analysis, right? So you analyze the data to tell the story that the data speaks of. And so this involves analyzing to test a hypothesis and to answer the research question. It's going to entail statistical techniques and for the researcher to then provide synthesis of the data. Data analysis may also generate new questions and new hypotheses for further exploration. And then the final step in scientific method of education is to interpret the results. Right? Interpret the findings and state your conclusions and report your findings. And by doing so, you want to confirm or disconfirm hypotheses. Conclusions are based upon analyses of our data and are stated in terms of the original hypothesis or research question. So the conclusions should make it very clear whether to reject or support the hypothesis that you created in the beginning of the study. So if you look at this diagram here, and you see that it's sort of like a wheel that's kind of turning, and you see when you locate step 1 at the very top, you see that when you take the steps all the way around the wheel back up to step 6, what comes after step 6 is back to step 1. And in doing so, we are seeing increase in knowledge, right? We gain knowledge in this cycle of doing research. So your step then in step 1 is to really learn and glean from other people's research, from somebody else's number 6, step 6, so that you can then ask the question that is practical, but one that has a significant contribution to the existing knowledge. So what's in a question? All in putting all things in perspective. These are really the basic questions that we ask in scientific research. What, who, where, how, and why. So the what question is, what do you want to know? And perhaps we're looking at high-low academic achievement. And who do you want to study? And so let's put elementary students as people that we want to study. And then the where question is, where do you get the data? What data do we want to look at? So maybe we want to look at the school data and the district data. And then the question of how does a phenomenon occur, and or why does a phenomenon occur? So that's the explanation of how high and low academic achievement occurs, or why high and low academic achievement occurs. So here's a full outline of a complete research study, and it's in 5 parts. So first, the research introduces the topic, and then discusses what we already know from the literature, and we call that the literature review. And then the methodology entails the process of how you're going to collect the data, whom you're going to collect the data from, and the timeline. All of that, all of the planning is discussed in the methodology. And then step 4 and 5 are results and discussion / conclusion. To the relevance of this to our course then is to focus on step 4, the results. To look at the data and try to make sense of that. So we'll learn different ways of collecting data. So when we talk about scientific method and we say that that's the best way to know something, going through the 5 steps, we also have to recognize that there are some limitations. We have to recognize that scientific method cannot answer all questions, especially those of a philosophical, spiritual, or ethical nature. And also, application of the scientific method can never capture the full richness of the context. And then there can be measurement errors, which poses as a huge limitation to scientific method. So 2 principles of scientific inquiry that we must understand moving forward is, one, as we've seen in the turning of the wheel diagram, that research is cyclical. It goes in a circular motion, and we learn from where somebody else is left off to continue to ask additional questions, and so that becomes a cycle. We also have to understand that results and conclusions are not conclusive, but tentative and when it warrants change. So when we come up with conclusions, it's conclusions for that particular study. But if there's contradictory findings or somebody else comes up with a similar or a different conclusion, then those conclusions are that need to be revisited. So we want to say that results and conclusions are not written in stone, and it's always tentative and warrants change. Let's talk about data. So we want to look at data, define what it is, and look at different types of variables so that we have a very good understanding of what data is before we go into analyzing data. So here's an example of data. It's called the Universal Pain Assessment Tool. I got this from a local hospital room when I visited one. And I saw this scale to help the medical personnel and the patient speak more clearly on the pain level of the patient, right? So you've seen this where the assessment tool goes from a scale of 0, meaning no pain, to 10, worst possible pain. To make it much more clear, they have word descriptions and diagrams, and I've seen them in different languages even. So this would be a form of data to help the doctors understand the level of pain the patient has. So data are pieces of information you collect to use to examine your topic. And you want to define or determine the type of data to collect. Variables then is defined as pieces of data that are measurable factors that has an effect on a phenomenon or phenomena. And a variable must have at least 2 categories and are placeholders that can assume any one of a range of values. And variables may be measured by instruments. So we're going to pause for a moment, and I want you to look around where you are and see what are some of the variables that you can see around you. Maybe you see colors, the temperature of the room, or the number of people around you. These are all things that can be measured, data that can be collected that may have an effect on something else. So when you collect data or variables, all variables fall into one of these 4 types. And it's important for us to know what type of variable you have, because as you will see later in the next lesson, we treat these variables differently in our analysis. So it is critical that when we have data, we know what type of variable they are. These 4 types of variables are differentiated by these 4 characteristics: categories, order, distance, and non-arbitrary 0. So these are characteristics that these 4 variables take on. So categories, just to define quickly what they are, is just basically a variable that has categories. So we already indicated that any good variable has to have at least 2 categories. So I'm just going to put a plus sign under each of these 4 types. And then you have order, and order has to do with some kind of rank order of categories. And distance is a measurable, mathematically measurable distance, so it pertains to numbers. And non-arbitrary 0 has to do with a scale that contains 0 that means the same thing to everybody. All right? So going back to the pain scale, if you said my pain scale, on a pain scale, my pain is 0, and I say 0 too, are we then at the same pain level? Well, our definition of 0 is very different, right? So that in that case, that 0 in the pain scale becomes an arbitrary 0. And so this characteristic is one where 0 in the scale means the same thing to everybody. Okay, so let's talk about nominal, for example. Nominal is the least complex of the four types. So it just has one characteristic. That's the basic characteristic, in which is categories. And so an example of that would be gender. Just has categories. There's no order. Distance and non-arbitrary zero do not apply, right? And then the second one is ordinal, and it has categories, and in addition to that has order. So an example of that would be military rank or t-shirt size, something that can be ordered. You will also notice that these two types that we discussed just now, nominal and ordinal, really pertain to the first two characteristics, but not distance or non-arbitrary zero, which refer to numbers. So nominal and ordinal types, these two are word variables, or what we call a categorical variable. And then the latter two, interval and ratio, would be what we call continuous or numerical data, because as you will see, they contain categories and order, because numbers can be ordered, and distance, because numbers can be calculated. And then the last characteristic separates the interval from ratio data. So interval data does not have the non-arbitrary. So sort of like the pain scale that we talked about, right? That zero in the pain scale means different things to different people. It's arbitrary, right? Whereas for ratio, that's the most complex of the four, plus sign on all four characteristics, and it contains a scale that has a zero that is non-arbitrary. It means the same thing to everybody. So an example of that would be weight or height or any measurable or any measurement tools that we use that's passed on through generations. So most of the data that we're talking about, or all of the data that we're talking about that are the four types, would really fall under structured questions. So let me define what that is in light of the other two types of questions that can be asked that we're not too interested in the context of quantitative data analysis. So structured question is the type of question where the respondent chooses the responses provided. So here's an example of one. How important is it to obtain high grades in school? Critical, important, non-important. So we have a predetermined answers to choose from, sort of like a multiple choice question. So that's the structured question where there's no place for someone to comment, right? And this would really be the quantitative data that we would analyze. But then there are two additional types of data that are pretty open-ended and allows for the respondent to respond with words. That's semi-structured questions and unstructured questions. Semi-structured questions do not have predetermined choices like the structured questions, but it's very specific. For example, what are some things that teachers give you that you like to do best? So of course, you're going to get answers that are positive, right? So it's very specific, but still open-ended. And then there are the unstructured questions that are also open-ended, but these are much more of a broad, general questions, like tell me about yourself, right? Where do you begin, right? So semi-structured questions and unstructured questions are sort of the qualitative kind of data that we will not touch upon, but working with the quantitative data, focus more on the structured questions. So in one of the handouts is the scale of measurement worksheet that looks like this. And in this worksheet are 10 different types of variables that one can measure. And so this exercise is to determine what the scale would look like if it's already not predetermined, and then decide which of the 4 types this data would be. This would help us to get familiar with the 4 different types of data, because then in the next lesson, we will talk about how certain types of data are analyzed differently. And then here are some spaces for you to come up with your own examples of the nominal, ordinal, interval, and ratio scales.